All right, another day, another video. It is 5:30 in the morning. I did not sleep. Would you believe that? It's all good. I got one of these. Bang. What was that? 300 megs. Pop one of these. Another 200 megs. We're at 500 megs, bro. 500. I'm gonna take one more. All right, so shout out GitHub followers, right? We got thank you for that. And we're gonna make the Pokemon sound of the day. That Pokemon is Golduck. All right, Golduck. So let's take a listen. What? Can't even say nothing. Golduck. All right. Now guys, I do have the interview on Friday. But I've done so much Leetcode like for the past like month and shit. Like, how much more brother gotta do? All right, so we got defuse the bomb. We're just gonna do that. I think we're gonna do one hard one because I have the questions, like the company questions that I need to do. Count number of fair pairs. Why am I getting distracted in this? Hold on. Oh, is it the binary search one? Yeah, it is. Yeah. Hold on. Sorry, I'm just kind of getting a little sidetracked here. How the fuck does this work? This works? But I'm sorting it. How am I getting the correct indices? Oh, because it's using the actual numbers. Okay. Right? 0, 1, 2, 3, 4, 5. Now, what is using the indices? Oh. Oops. Anyway, I'm getting a little distracted. Let's do the decrypt. All right, this is an easy problem we got today, so. Okay. What? Okay, if k equals 0, does this work? Can I do this? Yes, it does. Okay. If is greater than 0, replace the ith number with the sum of the next k numbers. How is this 13? Oh, because it's circular. Oh. Man, I'm thinking of an n squared solution here, but I feel like this should be O of n or something. Like there should be some pre-computation that you can do that's just like super good for this type of problem. But I don't know. I'm going to do it the n squared way because I think that's the way I'm supposed to do it. And I don't want to think about the other way at all. Like I don't even want to begin to think about it. Okay, 4. I got res. With the next k number, so 3. So yeah. I guess it's like this then, plus 1 while someone just went and used the bathroom at 5:43 a.m. If j equals line of code j is equal to 0. Cur equals 0. Account cur. And counter minus equals 1. And at the end of this, is res out of scope here? You're killing me. Yeah, there it is. We're back. I got none of these right. Oh, I never incremented j. There we go. And minus 2. I mean, dude, I don't want to rewrite this code with just like the slight variation. But I'm going to do it anyway. I guess it's more of an elif. But it's j minus 1. Counter equals k, cur equals 0. If j is equal to is less than 0, j equals len of code. And then j minus equals 1. Do I have an infinite loop here? Yeah, I do. How? Is counter ever going up? No. Counter equals K. While counter. You subtract from the counter. What's the problem? Oh, because counter is... Oh. Here we go. Yeah, it's to be expected. I think before I watch the Leetcode video, I'm not gonna attempt to think about how to solve this problem. I don't care. Oh, that's how you do that. Well, yeah, that makes sense. Because you would like start here, the window would be here, and then as you move here, you would subtract this number and add that number. And that's how it's O of n, and that's why my solution sucks. Man, I don't really want to redo this problem though. Like I really don't, but you know. I might have to just for the, I don't know. I actually don't know why I want to solve it. Because I just know it's the right thing to do, even though I'm not really sure why it's the right thing to do. And for some better habit or some fucking stupid reason I can come up with. Should be up here. Cur equals 0. While k is greater than 0. No. Fuck, I really don't want to think about this problem right now. Like the way I would do it, I'm not going to do it. I'm just going to talk about how I would do it. So I would, let's do this. So this k equals 3, right? So I would pre-compute. So this is my 0th index, right? I would pre-compute k elements. So in this case, it's 3. Which is 8, 12, right? So then I would know in the result array, I'd put 12. And then as I move, oh shit. As I move to here, I would subtract this 7 and add the 5. But I need to know how to add this 5. So I guess I would keep a pointer. Fucking always pointing to shit. Why do I always got to be pointing to stuff, you know? Yeah, I mean, I'd just be like R. Yeah, R equals 1 because it's 1 ahead of this one. Is k guaranteed to be 1? No, k can be 0, which in that case is... Okay. cur plus equals code at spot R, and R plus equals 1. Maybe they should be started at 0. They should be up here. And then K minus equals 1. And now we have the pre-computation. Res dot append cur. And after that, hold on. And after that, I got to do something else. Res dot append. Yeah, that makes sense. And I need to drop it. And it's cur. No, it's not that. Or is it? No, it's the next one. No, it's not that either. Wait, is it? So it is. So if cur minus equals code at spot I, and then we have to increase it by the next one. That's the O one. Just copy paste that. I didn't return it. Let's see what we get. Work for that one. Now can I copy this and do it opposite? Maybe they should probably go backwards. Figure that out after. R is equal to len of code minus 1 and R minus 1 is less than 0. R equals code minus 1. Yep. Yep. Oh, I guess it's K plus equals 1. While K is less than 0. If cur minus R minus equals, we gotta copy this here. shit. This is still slow though. This is slow. Okay, it says 100, but it's because I did the optimal solution, but this is slow. I kind of want to watch the Leetcode video, but I also just kind of don't. Dude, you watch like one video and it's just like your whole freaking homepage is full of garbage, bro. Like the Leetcode video is supposed to be here.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem, defuse the bomb. The idea is we're given an input array of integers. Show you the code. I'm going to create a separate array. So that's what we're going to do. We're going to put the new values in a separate array. So if k is 0, we can just return all zeros, and the length is the same as this. So that's pretty straightforward. The other two cases are a bit more interesting. If k is a positive number, we're going to do this. For every number, we're going to create a window of size k because we want to replace the ith element with the next k elements. So basically a window of size k in this case, and get the sum of that window. In this case, 7 plus 1 plus 4, I think that's 12. And so we take 12 and then place it over here in the second array. So we'll have a 12 over here, and we'll keep going. We want to do the same thing for this element. So get the next 3 elements, 1, 2. Now we ran out of elements. There's nothing left.
Dude, these guys always be making like the same thumbnail. Like it's always like this like weird saturation, like highlighting shit. Like, look at Leetcode's thumbnails, guys. Check this out. Look, it's just, wait. Look, it's just him. Is this the same picture, but like the shirt color's different? That's so brain dead. That's so brain dead. It's the same picture, I think. He's like editing the color of the photo in Photoshop or some shit. Wait, that's so brain dead. Wait, that's the dumbest thing I've ever seen. I'm not even joking you. Wait, it's this stupid picture. Wait, is this shirt green because it's an easy problem, and it's red because it's a hard problem? And it's yellow because it's a medium problem. Dude, what are you doing? Leetcode.
So one tricky thing about this problem is this array is considered circular. I'll show you a really nice trick to deal with circular arrays. So what we actually want to do is get these 2 elements and then the next element, which is technically out of bounds, but what we would actually want is for that element to have been considered to be over here. And so then we get the sum of all these. That's 10. We put it over here, and we can keep going just like this. So we do the same thing with this. That'd be, looks like 16. And for this one, it would be 13. So that's if k is positive. K can actually also be negative. So what if we had k is equal to -3? Well, then for each element, we want to do the opposite. We want to get the previous k elements. And again, since the array is circular, we'll go around here. 1, 2, 3. And so once again, we will get a 12 in the output over here. For this element, we'll do the previous 3. So essentially,
I was wasting my time watching this video, but I'm too deep in.
Value of k, and we're getting a window of that size. So this sort of very brute force approach that I'm showing you, clearly the time complexity is going to be O of n because we have to fill in every single value. And to fill in a particular...
it's times k. It's not n squared. It's times k.
...value, we have to iterate, let's say, k times for that window. And so this brute force solution is going to be n times k. I think it's worth coding up this solution, so I'll quickly do that. But before I do, let me show you that trick that I promised. So the trick here is actually very simple. Once you know it, it's going to make your life so much easier. Think of this. We get out of bounds sometimes, right? And those out of bounds indexes are going to be 4, 5, up until 6. Let's assume that k is equal to 3 in this case, or it could also be equal to -3.
Oh, it's modulo. He's going to use modulo. He's going to do the modulo operator. Check this out.
We're going to take k spots here because
that's not how I did it because I'm not a loser.
We might end up out of bounds. Like, for example, if we're here, give me the next k. If I'm here, give me the next 3. If I'm here, next 3, here, next 3, etc. So that's why I'm only putting 3 elements here. And the cool thing is you actually don't need to create more elements. You don't actually need to create a bigger array. You can do modding to like assume these positions kind of exist, like implicitly exist. So I'm going to draw them like in gray, but assume these elements are actually like, let's say these first 3. We get 5, 7, and 1. So when we do our pointer stuff, like let's say my I pointer is over here and I want the next 3 elements, I'll do a nested loop to do that. I'll have my J pointer iterate over this portion, and it works. When my I pointer is here though, if I have my J go through this portion, I end up out of bounds. But I wish that index 4 corresponded to the element 5 because that would make it circular. And the way to do that is to take each pointer and mod it by the length of the array, which let's say is n, and n is 4 in this case. When you do that, if my J pointer was over here at index 4, and I take it and I mod it by 4, I'm going to get 0. So that's going to tell me my J pointer isn't actually at 4, it's actually at 0. So if a pointer gets out of bounds, it will automatically be corrected. That's the advantage of this approach. And it actually works going the other way as well, if we were looking at the previous k elements. Because I'm going to do this. I'm going to have, let's say, my window, and I'm going to populate this guy. Great. I'm going to have my window populate this guy, which is actually populating index 0. I'm going to have my window, and I'm going to populate this guy, which is actually populating this index. Now you have a bit of the intuition. Let me show you the code. I'm going to create my result array. I'm going to make it all zeros of the size of the input, and I'm actually going to save
that's how you
that
avoid the
in
insert operation.
Because I think we're going to need it a few times. And next, I'm going to go for I in range n for every position. I want to populate this position. For that, I need to know if k is greater than 0, we're going to do something else. If k is less than 0, we'll do it differently. And if k is equal to 0, we don't need to do anything. We could actually have an if statement here. If k is equal to 0, just return the result. And then we don't even need to handle it here. This is kind of a small optimization. It doesn't really make a big difference. Our code below will actually handle this case anyway, so it's a little bit unnecessary. But we will, I guess, iterate n times, which is somewhat wasteful, but not a big deal. Anyways, here, if k is greater than 0, we want the next k element. So I'm going to say for j, starting at I plus 1, going up until I plus 1 plus k. This plus k is kind of the offset here. With Python, this is non-inclusive, so that's why we still have that plus 1. And so for this, we want to compute the sum of all of these elements and then replace result at index I with that value. So we might as well just add the values to this position because it's initialized as 0 anyway. We can do something similar down here, but we want to go in reverse order for j in range. I minus 1 up until I minus 1 minus k, going in reverse order. There's one little bug with this. K could be negative. In fact, it is negative if this is executing. It's positive if this is executing, so the plus k is fine, but minus k should be minus the absolute value of k. And honestly, I think they could have done a better job in the problem description here where they say replace it with the sum of the previous k elements. They could have said the absolute value of k, but anyways. And in here, we'll do pretty much the same thing. Result of I, add to it code of index j. And then at the end, we return the result. Now, this looks pretty straightforward, and that's because there's a small issue here. I'm not doing the modding that I talked about. My j pointer could end up out of bounds. It's definitely going to end up out of bounds in both of these cases. So what should I do? Well, we can just take it and mod it by n. And same thing over here. So that's the code. Let's run it. And you can see that it works, but this is not the most optimal solution. I don't think you will pass in an interview with this solution, but I guess it depends on the interviewer, the company, and a bunch of other factors. Now, how do we go about optimizing this? Well, once you know the trick, And if you've heard of the pattern called sliding window, it's not too difficult. If you haven't heard of this pattern, you can consider heading to Leetcode.io. If you go to the sliding window pattern, there's a bunch of problems here. And you can also check out the courses, which will teach you these things like from scratch. Got videos, practice will work, even though we could add an
It is like that. Cursome
statement up above.
He did the same thing I did, but he used this modulo trick, and this modulo trick is making it a way better.
If k is greater than 0, we want to update the value. Code works.
Bro, the 0ms shit's actually so... I really don't like how they did that. All right, guys. Let me bring out the list. Did I downloaded this like 4 times, bro? All right. What is this rotate array? Is this the premium one? I keep forgetting. Oh no, it's not. Is this a linkless problem? Array math. No. We got count of smaller numbers after self, bro. This is a hard problem, guys. We're about to do a hard problem. Brace yourselves. So let's just take a look. I'm not fully... It's so scary when it's red. Oh, but look how simple the problem is, bro. All right. How is this hard? Yeah, this is hard without doing it n squared times, actually. Okay, this is a cute problem. I like it. Count of smaller numbers after self. So the obvious solution is an n squared solution, where I just loop through this, count how many are smaller. Let's just get the TLE. Let's just do it. Let's just code it up, get the TLE, get the ball rolling. I like to do that. All right. Okay, for I in range... Okay, if nums at spot I is greater than nums at spot j, counter plus equals 1. And at the end of this, res dot append counter, and we return. Okay, just give it to me. Come on. We're going to get the TLE here. It's going to be all good in the hood. This is a hard... Would you believe that? Okay. You have to somehow keep track. Well, you know the rightmost? Okay, I'm noticing that the rightmost... Let me take this in So look, the rightmost will always be 0. I'm pretty... Well, yeah, because there's obviously no elements to the right of it. So... Yeah, so we always know this is going to be 0. How do I know? Is this a DP problem? Like, I don't... I'm trying to think, because, like, if I store this, right? Like, this 6 here, like, I look at this. Do I, like, compare with these? 0, 1. Since 2 is only bigger than 1, I take this one. Or I take this one plus 1. Yeah, that doesn't work though, because like what if this number is 3 and this number is 4? Then it doesn't work, and this should be 1. This is some sort of DP solution, I think. I don't really know what to store though. Nums.length is equal to n. Well, no shit. Do I just sort it? If I sort this in order 1, 2, 5, 6. Oh wow, what would that wouldn't do anything, would it? I don't think so. I think this was stupid as hell. Yeah, that wouldn't work at all. What would sorting do? Nothing. I'm not even sure like what like data structure, like could I use a hash map here to do something? I don't know. I still feel like it's a DP solution, but I don't know how the DP would work. Is this like a binary search solution or something? Where it's like I have it, it's like 1, 2, 6. And then I find, and like each number maps to like how many shits before it. And then I do binary search for like 5, right? And I like look for 5. And then when it's not in the array, I just check this one and I add 2 to it. But the issue is that inserting it's n log n on every insert. I don't want to do that. Man, I don't like that solution either. Okay. Wow. Really got myself into a pickle here. Man. Dude, I have no idea how to do this problem. Sorting doesn't help. I don't know, nothing helps, it feels like, in this problem. Oops. What is this? Layers? Dude, I have no idea. The issue I'm having is just like, how the hell what can I pre-compute to make everything be O of 1? Like, I need to pre-compute something in O of n, or maybe n log n, and then after I pre-compute, every single index should take O of 1. Like, I guarantee you that's the solution. Or it takes like log n, every solution's like log n or some shit, I don't know. Okay, let me look at the topics. I don't even want to do that, though. I kind of want to do that, but, like, not really. Oops. Wrong one. But, like, what if this was a 5? This would still be 1. All right, I'm looking. What the fuck? Oh, a binary tree. That's interesting. If I make this into a binary tree, what happens? Oh, but it wouldn't matter because it's not. What? I'm never going to be able to solve this problem. Okay, hold on. Bruh. No Leetcode video on this underground ass problem, bro. Okay, let's see what we got here. 18 minutes, bro.
Hello and welcome back to the Cracking Bang YouTube channel. Today we're going to be solving Leetcode problem 315, count of
I'll be right back.
smaller numbers after self. This is yet again another Google hard question, and I am pulling my hair out trying to solve these for you guys. So if you appreciate this sort of content, leave a like and a comment. It lets me know that my suffering is not in vain. Alright, given an integer array nums, return an integer array counts, where counts of I is the number of the smaller elements to the right of I. If we look at this basic example where we're given the array 5, 2, 6, 1, let's think about what our answer might be. So for 5, how many numbers are there to the right of it that are smaller? Obviously, it's going to be the 2 and the 1. So there are 2 elements that are smaller. For the 2, there's only the value 1, so we would put 1. For the 6, there's only 1, which is the 1. And then for 1, obviously there's nothing to the right of it, so we simply put 0 here. So you may be looking at this question and be like, wow, that was really easy. What's the fuss all about? Well, let me tell you that the way that you want to approach this question is actually very difficult. There's two kind of god tier solutions, which is to use a segment tree or a binary index tree, which is also called a Fenwick tree. Don't worry if you didn't know that. It just means that you're a human being and not some sort of robot. But we're not actually going to do that because, you know, we don't have 200 IQ here. We like human solutions that people can understand, that, you know, again, aren't robots or some sort of competitive programming fiends. So we're actually going to solve it using binary search. And we're going to achieve basically the same runtime complexity, except for you can actually understand the solution and you can actually code it as well. Because if you try to do the segment tree and the Fenwick tree, you're probably just going to walk out of the interview in tears because, yeah, the interviewer just crushed your dreams of working at Google. So, yeah, let's now wipe all of this away and think about how we can actually solve this using binary search like I hinted at. Okay, so I told you that we want to use binary search, but let's actually figure out in an intuitive way the way we want to do that. So one thing that I want you to consider is a very basic example where we have an example.
I'm not gonna lie, I keep looking at this YouTube short. I'm looking at this guy's, what is this, low-level program, whatever the hell this guy's name is. Dude, this Vim config, bro.
What do you think about breakpoint debugging versus
I just gotta look at it.
Yeah, they're both fine. It really just depends on the problem you're
Bro, look at this Vim auto
trying to solve. Breakpoint debugging and core dump debugging.
Bro, look how good that looks, bro.
Are
That's how I need to get. Mine looks so bad right now. It's kind of like unbelievable.
Much better.
Anyway.
Array, and in this array, it's going to be sorted, and there's also not going to be any duplicates. So if I gave you an index, could you tell me how many numbers are greater than it, right?
Yeah.
To the right of R2, it is however many indexes are left in the array, right?
Yeah.
Are greater than 2, right? It makes sense because it's sorted. So everything to the right of it will be greater than it. And then we also know that however many items there are is the number that are greater, right? So for 1, there's obviously 3 elements to the right of it which are greater. And then for 2, there's 2 elements. And then, you know, for the last one, there's 1 element for the 3, right? This is essentially what we want to tap into for our solution. If we have a sorted array, then we can easily figure out how many elements are smaller, right? Because if I gave you this index, I could easily tell you that there's 2 based on just the index that we're at, because everything to the left of it must be smaller. So now you're thinking, okay, well, why don't I just sort the array?
You can't do that.
The problem with sorting the array, and it won't actually work because you'll lose the original index positions of your items. If you just sorted it, it would actually mix up the indexes, and then I couldn't tell you in the original array relative to that number how many were less there. So what we want to do is we want to basically have our result array. We want to have our result. So this is going to be res, and this is going to be an empty list. And then we're going to have what we're going to call a sorted array. So we're going to say sorted, and this is originally going to be empty. So what we're going to do here is...
I knew it. I think I was right. I think I was right with my solution, but it's still n squared. So
we are going to go from right to left over our array.
Yeah, of course you are.
And what we're going to do is we're going to insert into the correct position each number we see. So what we want to do here is we want to insert our value.
That's it?
And we're going to insert, obviously, so let's see what sorted would look like after the first iteration, right? So sorted, obviously there's no elements in there, so we just insert it at the 0th index, right? So the index that we actually insert our value into the sorted is actually the number of elements which are actually less than us, right? So obviously there's no elements less than us when we only have one element. So therefore our result, we would add 0, right? And you'll notice that we'll actually, since we're going from right to left, our answer is going to be backwards. So we'll need to flip it at the end, but that's...
No, I think I get what he's saying. Okay, let's try it. So we need a def insert let me just... Oh, this needs to break. Why is it inserting this entire list? Bro, who told you to do that? How was it this whole thing? Oh, oops. That's how. One six. That doesn't make sense though. Oh, because this is not length of nums. This is length of sort. If sort. There you go. So if it that's not right anyway. Oh, we're not watching for duplicates anyway. Why is it 0? I don't really get why this is happening. Why is it 0, 0, 1, 2? One 6, 1 2 6. 0. Oh, this needs to be after. Now it works. Yeah. Can I do it in here? What do you mean it's out of range, dude? Is it just res at -1? Like the last element. No, it's still flipped. Is it the 0th element? That doesn't even make sense, bro. God dang it. Let me just print res here. See what's going on. There you go. Let's see if this passes. It is in fact not passing. Man. Oh. Wait, what? 5261. Wait, is it dead ass the same case though? What? Oh. Wait, what? Am I tripping? I mean, it's still not looking too hot on this judge. Wrong, bro, what? Oh, it's just a completely different number. Wait, what? I'm off by like 1 or 2 or something. I mean, yeah, that's pretty legit. I'm a little bit confused why this is not working. Are mine smaller than it? They are, right? Wait, so why can't I insert... Wait, why can't I do this again? I can. Then what's the problem? Is it just slower or something? Like, I don't really get the problem. I still TLE though. Wow. This is deadass a lot of numbers, bro.
It's not a big deal. And now what we're going to do is now we need to process the 6. So we're going to figure out where can we actually insert the 6 here such that it will be in the order. So either we could put it before the 1 or we could put it after the 1. Obviously, since we're maintaining a sorted order here, we want to put it after the 1. So 1, 6, right? And let's think about this. This got inserted at the first index, which means that there is one index to the left of us, which is actually smaller. So now we would add 1, because we inserted it at index 1, to our result, right? Then we move on to the next number, which is going to be 2, right? So where can we insert 2? Obviously, it can go before 1, it can go after 1, or it can go after 6. Obviously, we're maintaining a sorted array here, so it's going to be 1, 2, 6. And that was inserted at what? It was inserted at the first index again, right? So that means that there is one item that is smaller than our current value. Great. Now we process the 5, which is the last element for us to process, and we want to insert it. So where would it go? Obviously, it's going to go between 2 and 6. So this is going to be 1, 2, 5, 6. So where was this inserted? This was inserted at index 2, right? Which means that there are 2 elements to the left of us, aka smaller than us. So 2. And that is your final solution. And remember, this is backwards, so we need to actually just reverse it, and we'll get 2, 1, 1, 0, which, if you remember from our original drawing, is the actual answer here. So that's all we need to do. We have our result, and we have our sorted array. We're going to go from right to left and insert our element every time. Now, this is where the binary search actually comes in. Because our array is sorted...
Oh, I'm an idiot. You're supposed to do this with binary search. Oh. Oh. I'm an idiot. Okay. And at the end of it, you would need to I don't think this is going to work off the box, but maybe it will. Is it R? No. No, it's not. Oh, it's more than one. I did one of these in reverse, maybe? What is M like -1 or some shit? That doesn't even make sense, bro. Yeah, okay. These aren't like backwards, right? Oh, it didn't. Well, obviously that didn't do anything. I don't know why I thought it would. They're like literally all like +1. But why? I think it depends on something here. Like, if I do +1 here, it breaks it. Now it's 3. Now this is... That's right. It's off by a lot. Is it the min? Not even close, bro. It's not the max, right? I'm just guessing at this point. I mean, no, it's the same problem as before. Like, we're like, I don't know. See, this is a +3. This is, I need to see the code. I'm going to be here for all day.
To figure out the insertion index, we can use a binary search, which is basically going to give us log time complexity. And we're going to do this for every n elements, right? So n log n, right? In the worst case, for us to actually do this for everything, right? So that's going to be the time complexity of actually inserting it. And that is why we do that. So we don't have to deal with it, and it's not the most left. Then your answer len nums standard binary one, then we'll actually erase it. So we want to just return left at the end. So that is going to be how you implement a bisect left. I have a feeling that your interviewer may ask you to actually show them how bisect left is implemented if you choose to use this the class method. Unfortunately, we can't use this one. It just doesn't work on this class. It's not compatible. Hopefully they don't ask you how sorted list is implemented. If they do, GG, that's it. But yeah, I mean, the intuition is basically the same, right? We want to insert it, we want to find the index, add that to our solution, and then insert it at whatever that index was.
What? I don't get this at all. You never even use this function.
So actually result actually needs to be reversed here, because remember that we insert it on the left and then we keep adding it back here using the sorted list. Maintain -1. The number is we want to set it up as a standard binary search. So left equals 0, right equals the length of the container. And we use len container instead of len container -1 because we are moving the indexes down. And typically when you do that, you set it to len container. So we're going to say while left is actually less than right, we're going to say that mid equals to left plus right, divide by 2. And then we're going to say if container of mid is actually less than the insert value, obviously our midpoint is too small, so we want to move our left up, right? So we're going to say left equals mid plus 1. Otherwise, we actually want to say that right equals mid. And the reason it's not mid -1 is because remember, we're trying to move our pointers down as far as possible. And if we said right equals mid -1, right could actually be, or the current mid could actually be our best solution. And if we do mid -1, then we'll actually erase it. So we want to just return left at the end. So that is going to be how you implement a bisect left. I have a feeling that your interviewer may ask you to actually show them how bisect left is implemented if you choose to use this the class method. Unfortunately, we can't use this one. It just doesn't work on this class. It's not compatible. Hopefully they don't ask you how sorted list is implemented. If they do, GG, that's it. But yeah, I mean, the intuition is basically the same, right? We want to...
Bro, what?
insert it, we want to find the index, add that to our solution.
Yeah, I don't like the solution at all. All right, let me just look at some of the 6 lines. But you're using this bisect left shit. You can't just pull out the bisect left, bro. These people are cheating. Like, holy shit. Enum? We're using enums in Python? I didn't even know Python had enums. What? I think I need to revisit this problem tomorrow. Bro, you can't pull out this bisect left. What is this? Zero, one. I mean, that makes sense, but like... Gnomes at spot I, bisect left, scene, and N, which is gnomes at spot I. And you do this in place. Wow. Oh, I see. This is looking an insanely nice solution here with this bisect thing. Let me see if I can just do it without. I don't know what that is. So, okay, so scene. Okay, 4. And you want to go through it backwards because that's just, you're just like that. Always be slouching. So it's, what is it? He calls it N. So container and then the number N. Scene dot insert. And then you just return gnomes. This passes. Well, it does something. Okay, how is this different than what I just did, bro? Oh, and that's why. Take a break. Be right back. All right, guys. I'm not gonna lie. The lack of sleep is starting to hit me really hard at 7:33 a.m. At this point, I don't think caffeine is gonna help me. So we're just gonna work on the project a little bit. Now, I will say I actually did fix it, what was not working. So here's what we have so far. So I have this board, right? And I click space, and you'll see that it solves it. How fun is that? Okay. Now, draw numbers. Yeah, so my goal for now, short-term goal, is I want the original numbers to be blue. And the new numbers to be black. But I think there's a problem with that, because when I call the draw function, it resets the entire thing. So that's not good. Yeah, see? Maybe I have the original. I need 2 grids then. Right? Do I need 2 grids? I think I need a private variable. STD array. Yo, what am I doing? Original grid. Okay, and I need to copy the grid into the original grid. And I need to do this one time. And how do I do that? If I would just do it here. Void Sudoku board copy grid. Oh wait, that's the original grid. There you go. So I need to call this in here. Sudoku board dot copy grid. And then in here, if just genius level programming, everyone. Genius level, let me tell you. All right. Let's write some comments and shit. Like, what if I change this to a 9? It breaks pretty fast. You guys can see I'm using this like milliseconds thing. Maybe I can make this go even faster, like 25. I'm just nitpicking here. I'm just kind of... That's probably too fast. I think you want it to be a little slower because you want to see the thing. Anyway. Number of steps would be interesting. Okay. Different Sudoku solving algorithm. Sudoku using bit masks. Wait, there's 2 methods above here? What's the 2? Naive approach. Okay, well, I'm not doing that. Wait. Wait, I'm confused. How is this not backtracking? You're literally backtracking right here. Wait, this doesn't check if it's safe? But it does though, is safe. Wait, what the fuck am I doing then? If I'm not backtracking, then what am I doing? Yo, what? L equals 0? But how is this any different? How is this not backtracking? Dude, I'm dead ass confused, bro. How is this not backtracking? You're literally doing the backtracking step, bro. Look, you have this base case right here, and you have this. No way. Wait, the backtrack? Yeah, it's right here. Oh, I guess he has it outside of it. There's some shit. He has it all the way out here. Outside the if statement. So if I do that. Is this slower? What? Okay, well, let me just time it. Let me do the good old clock method. All right. I'm a programmer, by the way. We got, you see it? 5 seconds. 5.09. I really don't know why this would matter. But okay, so we got 5.09, and then we got five. It's the same shit. It's the same thing. 5.16. That has the same thing. Does it matter where this is? Bro, am I tripping right now? I'm so confused the difference between these right here. I'm literally, this is the backtracking step though. You're making this, make tentative assessment. You're trying it, and if it doesn't work, you unmake it. That makes sense. Okay, what the fuck is this then? Dog, this is the same thing. Okay. Dude, nah. I actually don't believe him. I don't believe the author of this. First, checks if current cell is greater than 0. Second, specifically searches for empty cells. Oh, so they're both backtracking, but the other one just isn't like terrible. So apparently this one is shit. So I need to do this one. Solves. Okay, yeah, I got it. What is this L? L is a list. Bro, this is like bad code. Like, what is this? Int grid n. Okay. Is this really the only improvement? This find unassigned location? Dude, what? Bro, I can't be the only one who's dead ass confused right now. I just don't. The first solution iterates through the grid sequentially row by row. The second solution uses find empty location to jump directly to empty cells. Oh, it does it now. Come on, let me just... I don't understand this find empty location function at all. Like, what's the point? What is this? L spot 0, L spot 1? Is this like a tuple? What'd you call it? You called it find empty location? Oh, and all of a sudden we want to change the name up. Find unassigned location. These guys, dude. But I don't get it. You just return true here, though. How is that useful? Is this really better, though? When are you defining these? It's just a grid. When are you defining it? Find unassigned location, grid, row, call. Are you assigning them in here? You can do that? Oh my god, you can do that. Oh my god, that's what you're doing. I mean, maybe. Extra qualify. Oh, yeah. Okay. So I'm gonna need this private. Maybe not. Excuse me. Maybe not. I need the void. The find unassigned. Okay, bool. Find. Can I say empty? Okay. How is this also not? I don't know. I'm not really seeing how this is better. Okay, int. Okay, if what is the say function? If check possible. There we go. Yeah. And if better solve backtrack. I don't know. Oh yeah. Okay, that feels faster than 5 seconds. Okay, that was like way faster. I don't know if the camera can really pick that up. 281? Yeah, that was just way faster. And I don't really get why, to be honest with you. Kind of seems like some magic. Not gonna lie. Yeah, I don't get why that's faster. I really don't. I kind of copied this. I just did it in C++. I mean, I get what it's I get it, but like, you're resetting them every time though. So like, how is this? Okay, let me just read this whole thing. Numbers 1 by 1 to empty cells. What the hell was I doing before? It's the same shit. 9 to the n by n. What is this? 9 to the n by n. So what's the what? Okay, the pruning. Okay, but where's the pruning happening? How many methods? There's a Sudoku using bit masks, Sudoku using cross hatching. Huh. That's pretty cool. All right. No, I like really want to understand why this works. I'm not gonna lie, I really don't get it. Wait, check that. Wait. Check whether it is safe to assign. How was this different than what I was doing before? I'm dead ass so confused right now. If grid okay. I'm doing the same thing though. I don't. It's literally, this is the same block of code as this. It's like literally the same thing. Pretty sure. Except yeah, instead of, I use some different variable names like an idiot. So the top, the only difference is this top thing. Yeah, I don't know. Um, on a mostly filled board. Okay, could have just said that. Okay, that makes sense. All right, let's go to the next one. Create a bit mask, and for each element in the grid, set the bit as at position value to 1. What? Create 3 arrays. Okay, I don't really know why I have to do all this shit. Okay. Where's the bit mask? Dog, Did I save and take one of those? I mean, you're just backtracking outside of here. How is this different, bro? For every unassigned index, there are 9 possible options. Wait, checking if a number is safe to use is much faster at O of 1. How is it O of 1 all of a sudden? I spilled my water, bro. Fuck. Well, not that bad of a spill, but nonetheless. Man. Okay, it was kind of a bad spill. Gotta clean it up. What an idiot. That's why I always keep napkins at the desk, I guess. I'm about to use up all my napkins for this. All my desk napkins. That's what I get, I guess. All right. Yo, dog, how are you doing this in O of 1? Huh? How the fuck were you doing it before then, smart guy? Bro, you're doing the same thing. What? Bro, am I missing something? Is this just the worst? Is this like the most poorly written like article ever? Create 3 arrays of size n. Where are you doing this? Why are you doing this? I don't get it. I don't think this is different. Like, I'm actually convinced this is not different. Yeah, okay, so yeah, so this is just not using the bit masks, guys, at all. Oh, now it is. So it's just this guy's an idiot. Oh, but here it works. What the fuck? Void set initial values. Dog, what am I even like reading? Can I look up a video? Sudoku? Bit mask. Can I go on the Sudoku bit mask?
the indices of a 3 vector, a function for the indices of only the join of the placements.
What? This is intellectual entertainment, but I can't imagine programming like this in a million years.
Place a matrix.
What the hell is APL, bro? How is it invalid, bro? Bro, these teams are not doing anything. All right. How is it invalid? What? What? It should solve it though. I mean, this is pretty chill, I guess. I don't know. Function solve. It takes all of these parameters. It outputs a Boolean. Bro, what the Dude, I need someone to explain this bit mask situation to me. I don't get it. Who is this, bro? This is a hard problem on Leetcode? Really? Really?
We're going to talk about Sudoku.
This is a hard problem, bro. I can do this right now. Wait, why am I low-key getting distracted, though? Fucking Sudoku, stupid. Okay, So we got def check. Row call num. Now I need the if you get 0, 1, 2, 3, 4, 5, 6, 7. 7 divided by 3 is 2. Okay. Equal to num. Okay. Def. What the hell is this comma here for? Oh, I'm tripping. I'm trying to remember what the solution looked like. I guess it's empty, I'm pretty sure. if. Check. Should be no. Num. That returns true. Then board. That's zero. You're not allowed to be zero. Oh, oops. Yeah, that'll be why. Time limit exceeded. I don't like that it's time limit exceeded. I don't really get why it's time limit exceeded. I feel like oh, that's what I do. If yep. Yep. What? Fuck off. Oh, now we want to... What is going on, bro? MRV heuristic. Okay, I'm gonna have to take a break here. Take a break. I'm done probably for the day. Well, I'll just pause it. No, I'm done for the day. So let's just commit this. CD ...